Okay. Uh, Hello, everyone. I'm Dr. Vishal Sharma, Senior Lecturer and Research Coordinator at EIT's Melbourne campus. I, along with Professor Akhtar Kalam, EIT's Academic Board Chairman, and Ms. Indumathi, EIT's Deputy Dean, would like to welcome all the participants, colleagues, and the students attending this webinar. The webinar is on Doctor of Engineering overview. Now, before we commence the webinar, let's pay tribute to our great country where we are, Australia. We acknowledge the traditional custodians throughout Australia, pay our respect to elders, past, present, and emerging, and extend that respect to any Indigenous people present today. Now, here is the agenda for today's session. So, introduction to EIT will be done by our Deputy Dean, Ms. Indumathi, and introduction to Doctor of Engineering program will be done by Professor Akhtar Kalam. And the more detailed part, starting from entry requirements and onwards, I will be doing it. You will also hear from our DEng students, and towards the end, we'll have the conclusion and QA session. Now, just to begin, a brief introduction about me. With 25 years of experience in advanced manufacturing, I have published 100 plus scientific articles, earning an H index of 35 on Scopus. Recognized as 2% researchers by Stanford Study and NRF rated researcher in South Africa, I serve as associate editor for prestigious journals. I have supervised 14 PhD students, 28 master students. My experience spans France, South Africa, Norway, and India, including successful completion of 3 industry projects. Now, it's time to introduce our leader. The leadership matters. Uh, our Deputy Dean, Indumathi V, is a chartered professional engineer with 20 years of experience in electrical and electronics engineering, excelled as the North Metropolitan Trainer of the Year in 2017. She holds a bachelor's degree in electrical and electronics engineering, a graduate diploma in adult and vocational education, and MBA. Indumathi is a fellow of Engineers Australia and Australian Institute of Management, encouraging women and girls in STEM through mentorship. Her dedication to education is evident in her pursuit of a PhD using EEG sensors for data analytics, aiming to empower both students and lecturers. She is an accomplished professional and researcher in the field. I would request our Deputy Dean to introduce EIT to the participants. Please welcome.
Thank you very much, Dr. Vishal. And hello, everyone. Welcome to today's session. We're going to run through some of the program aspects of the Doctor of Engineering program, one of our flagship program, and actually ably started by Professor Akhtar Kalam. He put the seed for starting this program for us many years ago. I just want to cover a little bit more about EIT. Most of you may have been present in the few sessions in the past few days, so you might already know about EIT a little bit, but for those who are joining us new today, one of the critical things, or I would say things that keeps us apart, is we are one of the only institutes purely specializing in engineering, I would say, engineering and technology. So we don't do arts or we don't do management, we purely do engineering. And what that helps us is to focus our resources and our efforts and the quality improvements in purely engineering education. Our programs are industry oriented, and Professor Kalam again would be able to say he sits in our course advisory committees as a chair. So we have industry input in all our program design and make sure that what we are creating is going to be useful out in the industry and what's needed in the industry, which means when you graduate, you're industry ready to go out and find job and do your engineering. We've got good accreditation across, so most of our programs are accredited, or all of our programs, I would say, are accredited under the Australian Tertiary Education Quality Standards Authority for the higher education side. And some of our higher education programs are also recognized under the International Engineering Accords, mainly our bachelor's and master's. And as you would and both our staff and students are also from around the world. So we don't rely on just a talent from one part of the world. We are able to tap into resources from different parts of the world. So you might have a professor, if you join our DH program, teaching you from, for example, Spain. Some of them may be teaching you from the US, South Africa, India, Australia. So it depends on what subjects and what you're doing. Similarly, your supervisors would be from around the world as well. Now, the benefit of that is that we are able to get you the best of the best and not rely on, like I said, the local pool of talent. And you also get a global perspective of your education, both in research as well as what you're learning. In terms of delivery model, we do offer a unique delivery model where although our programs may be online, we don't rely purely on just recordings. We have live sessions where we're able to interact with students. Students are free to ask questions and interact with their lecturers and supervisors so that they get the best out of the hybrid program. You also would get a dedicated learning support officer when you're studying with us. These are support staff, not academic staff, but these are support staff who help you to make sure that you're tracking along well. So if you're not attending your lectures for a few weeks in a row, for example, you will get a call or a message from your learning support officers to find out if you're doing okay or if you need additional support. And similarly, people might ask, how do you do engineering online? And we do have the state of the art remote laboratories and virtual laboratories where you have access to software as well as hardware that you can access remotely 24/7 from anywhere you are, and you're able to do your practicals anytime, anywhere. So that's just a little bit about EIT and our delivery methodology. I would now like to welcome Professor Kalam. Professor Vishal, would you like to introduce Professor Kalam?
Uh, yes, thank you, ma'am. Thank you for introduction to EIT. Now, the next speaker we have is Professor Akhtar Kalam. So it's a privilege to introduce Professor Akhtar Kalam. Professor Kalam is also head of the external engagement at Victoria University, Melbourne, and a former deputy dean. He holds distinguished professor appointment at multiple international universities. As the editor-in-chief of Australian Journal of Electrical and Electronics Engineering, he has extensive publication record, authored 29 books, and supervised over 40 PhD students. Professor Kalam serves as an external examiner for doctoral students both in Australia and overseas, specializing in power systems, communication, renewable energy, and smart grid technologies, among other areas of expertise. Now I request Professor Kalam to please introduce Doctor of Engineering program to the participants. Welcome, sir.
Thank you very much, Dr. Sharma and Dr. Indu, for all the wonderful words you've said about the program. First of all, let me tell you, it's such a delight to see such a huge gathering and on this session on the DEng program. The reason why I say huge gathering is that this is a unique program, and by your presence today, it appears to me and to all the people in EIT that there's definitely an interest in knowing what this program is. This program is a bit different than what you know. It is not a PhD, it's not a traditional PhD. This is a professional doctorate program. By professional doctorate, I do mean that there is this original and significant contribution to the development by engaging in practical problems is to be highlighted whilst people are there in their employment. And so there is a win-win situation, not only for EIT, not only for the student, it is a win-win situation for the industry, for the government, for the business, the whole lot of sector. So this program, I must admit, has accreditation from TEXA, which is the formal body which gives the accreditation, and it also gives us that quality assurance and regulatory framework which is there in higher education. The highest level of qualification like a PhD program. This too has a level 10, which is the highest level in the Australian Quality Framework program. Duration is 3 years full time. Because there are many students who are working in the industry, there is option to do it part time too, and that's equivalent. If you are 3 years full time and you want to do the whole course part time, then you can do it in 6 years. But normally I find that students try to accelerate because technology is moving very fast. They do it between 4 to 5 years time. Delivery can be both online and offline mode. It's online or on campus mode. You can be in one of the campuses here in Australia, either in Perth or in Melbourne, or many students are also online. I mean, I've got 6 students. One is in Perth, two is in Sydney, one is in Saudi Arabia, one is in South Africa, and you will hear from the South African student Garth. He's my student too. Uh, he's from South Africa, one in Ireland, and one in Saudi Arabia. So it's a very unique program which has both the component online and on campus. Structure is very simple. 30% of the course is by coursework, 70% is by research work. The research work gives you that dissertation, which is the thesis that comes at the end of it. Then after that, many people ask me, what's the difference between DEng and PhD? And this is a very valid question. The DEng program is of direct relevance to solving industry problem, whereas a PhD program is in a very small research focused area which is just for academic or scientific research. So around the world, you find there are a lot of PhDs. I also have a PhD. Dr. Sharma also has a PhD. We all have a PhD. But I'm quite sure that our PhD was in a niche area, in a very small area. And if the opportunity, at least I can talk about myself, if an opportunity was given for me to study again for a doctorate program, I would go for a DEng program. So if you want a real good outcome, which has a fantastic value and a solution which can be considered seriously, then this is the option. And you find that slowly and steadily, some of the great institutions are seriously considering this type of program. So, this will assure you both not only the academic but the scientific research career, and I'll talk about that career in a minute, but you are going to be an engineering working professional and you are solving a problem that will benefit the industry and society at large. This is the reason why you would be considering seriously doing a DEng program. Few of the outcomes which we have is in a traditional PhD program, I know that there is hardly any supervision or support. uh, there is very tight supervision uh, is not there, okay, and the emphasis over there is on pure research. No one is bothered about practical outcome, and there is hardly any coursework. And this is a very big element because you do not know about the methodology, about what you are expected in the candidature. You do not know how to write a technical paper, so therefore you are thrown in a deep end and you are supposed to work this out. Whereas in DH program, that's 30% of the work that you'll be doing in coursework will definitely enhance that knowledge. And the time, is in PhD program is a very long time to complete. And I remember when I did my PhD long time back, at that time too, many students need to take 7, 8, 10 years. Here, we are not interested in there. We want very quick return. That's why I said 3 years, not 4 years. You go to any other universities in Australia, they look at 4 years program of a PhD. We are definitely with a 3 years time, with a 3 years time, because industry cannot be without you for a long period of time. So what we have crafted is a professional doctorate program. There is applied research, right, with practical application. We are trying to make you technical leaders. We are trying to make significant support systems that is there to help you. And it is online or in blended model. And there are a lot of support, collegial support. And remember, the supervisors or lecturers or peers, whoever they are, not necessarily locally to where you are. I am there, and I've got, as I told you, I've got students, hardly, as a matter of fact, no one is in Melbourne. None of my students are in Melbourne. I did tell you they're in Sydney, Perth, South Africa, um, uh, Saudi Arabia, Ireland. So it is necessary that you understand that we are looking at high quality applied research, and also you will find a very unique thing in EIT. There are LSOs which are dedicated to help you. Okay. Uh, and We believe that EIT program has worked with a very high quality applied research, and some of the work that has gone, and some of the students who have recently gone through candidature, uh, in people from universities, external people who were there in the presentation, have remarked that these students are better than their universities are. So I think that it's a very good thing. It's a hybrid thing which is helping both the university sector, someone in the workplace, and the profession. So altogether, everyone is a winner. And if you look at the course structure, I did mention to you there are coursework elements, and those coursework elements are basically to give you scaffolding to your research, building the foundation so that you can do the research. Research is divided in every part of the year. Naturally, the last year of the program, you have the maximum, the 4 terms is all research, whereas in the other 2 years, there is combination of coursework and research. Now, as Dr. Indu has already mentioned about the contribution of EIT, this is nothing unique. We have it for all the course, but I do want to mention quite clearly it is flexible. So that means it'll suit you if you're working in the workforce. The delivery model is unique, and this is not new for this DEng program. EIT has been doing this over 10 years. So we've got this all sorted out. Many universities in Australia and other places learned a bit on the online model teaching in the COVID period, but we have been doing much before that. It's industry oriented, so therefore it's applied and very focused to the industry. Work integrated, that means it links the education to your workforce. It solves your workforce problem, and it takes issues of your workplace, not a figment of imagination of a researcher. The research is independent. You have to do it yourself, right? There's a research problem which you design, or we help you to design one problem. Contribution, it prepares the candidate for the highest level, as I said, AQF 10. Now, what are the job outcomes? And this is the most important slide I have. Many people ask me, what will I become after that? Will I get a job in an academia? I will tell you, I can assure you, you have a better chance of getting a job in an academia, because academic institutions are no longer interested in just pure researcher doing teaching. They want someone who is being teaching as well as though have the industry experience too. So someone who can communicate effectively, contribute to the local international profile and reputation. Therefore, these are the type of talented researchers that the universities and higher education sector wants. Now, business also, they want to develop and improve their products so that they can have their sale properly. So therefore, that is an opportunity for the private sector too. The government agencies, right? Now the government agencies are looking for someone with specialist knowledge, a holistic knowledge, not really focused in a very small area. Therefore, there is a lot of agencies who are looking for this type of professional doctorate. So it's the academic sector, the business, the government agency, all in all, everyone is going for a graduate who has a professional doctorate program. Thank you very much, Dr. Sharma. I complete my presentation.
Uh, Thank you so much, Prof, for this elaborate explanation about DH program. We really appreciate your effort. Thank you so much.
You're welcome.
Okay, so now next is entry requirements. If someone wants to get into the program, so what he or she should have. The first requirement is BE honors with the graduate diploma. That is the first criteria. Or you should have a master's degree from EIT or any other recognized tertiary institution. The third requirement could be this is again or so 4 years of undergraduate qualification with 5 years of professional experience, and then meeting level of English and everything put together. You should be able to satisfy the requirements of the dean as led by the dean, and you have to meet the those requirements. So there are three levels at which one can. There are three criteria. Out of these three criteria, one criteria you should meet in order to get into the program. Okay. Uh, Regarding the pathway and credit, we do recognize and give credit for previous studies, but no recognition of prior learning is given for research component. RPL is credited for coursework maximum 2 units undertaken at master's or DH level. So that is possible. Now, how to apply? The procedure is quite simple and user friendly. What you have to do is fill the form. Our EIT course advisor will call you for discussions. Then you receive an email for the complete with the complete details and a link to apply online. Your application should include a resume, statement why you want to do DH program, and a research proposal. And if you wish to discuss the research proposal with our academic team before filling the form, kindly let our course advisor know. Once you submit the application, our admission team will assess it and forward it to research committee, and thereafter you will be interviewed by the panel, and if successful you will receive a letter of offer. This entire process would take approximately 3 weeks time. So we do offer a lot of student support. We as pointed out by Ms. Indu and Professor Kalam also. So this support comes in the form of we give support to the students from administrative perspective. We ensure that students get proper research guidance, and we also ensure that students get proper laboratory access and have access to our other resources, laboratory like library and other resources. We do have some scholarships also for this program. Now, the first scholarship that we have is EIT's Doctorate Research Scholarship. This is given to both domestic and international students, and but the main focus is we give it to only on-campus DNG students, and we have 4 scholarships per semester. The second one is EIT's Dean High Achievers Doctorate Scholarship. Now, again, it can be given to both domestic and international students, 2 scholarships per semester. And what we cover here is we give discount of 25% on the tuition fees. We also have a few assistantships available where we engage our DN students as teaching assistants and graduate assistants, where they will be helping our academics in the routine activities in the laboratories or marking of some assessments. What they get here, 10% discount on the tuition fees, and in addition to that, they are also paid on the basis of hourly basis based upon the time for which they are engaged. Now here is we have these are like DNG supervisors. We have a great network of Doctor of Engineering supervisors with the many Australian universities. In fact, many of them are from other countries as well, like Brazil, Canada, UK. These are here just 2 to 3 slides are presented just to give you an idea. You heard from Professor Kalam just now. We have Professor Vivian, Professor Mehran from Australia, and we also have professor from Brazil, Canada, and UK, and so on and so forth. So these are our internal core team situated at Perth and Melbourne campus. Dr. Aarti, Dr. Anna, Dr. Hari Singh, Dr. Milind, Dr. Fan, Dr. Shasha, Dr. Akhlakur, myself Vishal, then Dr. Arvindham, Dr. Dipali, Dr. Igor, and Dr. Hossein. Now, just to give you an idea about different topics on which our students work, if you go through it, you can easily make it out. These are the different topics. If you want to categorize them, so they can be categorized in like civil engineering, mechanical, electrical, and industrial automation. But normally, any research is interdisciplinary in nature. So you will find in almost every topic there is in cross-disciplinary component associated with it. So which is actually the need of the industry. These are the topics. Just I'm scrolling through the topics. Now, regarding the time commitment, as it was already pointed out, so we have to, anyone who registered for Doctor of Engineering program has to complete 120 credits. It will take 3 years of full time. And the student has to spend at least 20 hours per fortnight on coursework unit and minimum of 60 hours per fortnight for the research units. So these are some of the important dates. If you want to apply for our program, you must take into account these important dates. For online intakes, the important date is 2nd of January 2024. And on-campus intakes for Melbourne and Perth, the onshore applications for that, the date is 29th January 2024. Offshore applications, the deadline is 5th of January 2024. Now it's time to hear from our DN students. They are winner of 3-minute thesis presentation. But before that, let me give you what is this give you an idea what is this 3MT. We organize DNG conference every year. This is an annual event where DNG students get an opportunity to showcase their work to their peers and other academics across the disciplines. And in this event, we recently concluded in September. This was for 2 months, 2 days in September, 20 and 21st September 2023. So here we had 5 keynote addresses by eminent experts in their domain. We also had 2 workshops and presentations done by the Doctor of DN students. In this, we had one 3-minute thesis presentation where we had first and 2 prizes, first and second runner up, and these are the DN students which you will be hearing now. They are the winners of this 3-minute thesis presentation. Okay, the first student we have Mr. Jules Bikoka Batumba. So I welcome Jules. So he has joined all the way from USA. Maybe it's midnight there. Thank you for joining. May I request you to give a brief introduction about you and what kind of work you're doing with EIT in this DNG program. Over to you, Jules.
Thank you so much, Dr. Vishal, and thank you so much, everyone on the other side. My name is Jules, and I've been with IDC, and today we call EIT, for more than since 2007. That's where I started. Simple certifications, and I've gone through so many stuff, different postgraduates, master's engineering. Right now, I'm a student doing my doctorate. Very satisfied with the program, which I always enjoy it, and wonderful lecturers and professors leading, guiding, mentoring, and obviously assisting with different projects we're working on. I've been so grateful to be part of these huge institutions, and Basically, I'm developing my topics, which is basically my research, and my research is basically based on what we actually experiencing in our company. I think one of the lecturer emphasized about it that the DEng program, it's practical program. You solving the actual program you're going through in your industry or your company. And mine, basically, we do have AGVs. If you look at it on the left, AGVs are known as a super machine able to lift up any weights. So we got engines which are really, really heavy. And these super machines are must deliver this machine to the line assembly. But we do have problems, and we the AGV got this attitude is made to follow the magnetic field, and most of the time, if you look at the path, these black spot on different locations, you can see that these are just forklift damaging these lines out. Every time we get these damages, obviously it's money, and nobody likes to see the money running away because we got money versus time, and that's what it calls our production. That's how we meet goals. We do have like we do produce 200 trucks a day, and the cheapest trucks is about 400,000, and the most expensive is about 800,000. So all these trucks are already fully paid, and customers are waiting for them just after 2 days. So 2 days of making these trucks, and then make sure that we meet the deadline, and this must be produced, going through all the testing. So any obstruction, any gap become an issue. So that's approach that came up on my level because this AGV, we do have almost like a 200 AGVs. It's basically 80% of our production in the line. If one of them got a problems, you get stuck completely. So you don't even know what to do. So my approach was is project versus the budget, and to look at what would be the easiest way we can implement this project. So I took the easiest way where I can improve the system, optimizing the system, bring it up in point where we can have a very sophisticated camera being able to analyze every change of the pattern on the magnetic field. That one. Secondly, being able to fill these lines, even though they are no longer existing. They can fill it, they can loop around and keep checking it and make sure that whatever the line within a certain range can be completed, projected, and in the same time report back to the technical department so that technical department may know which sections of the path is missing. So this is one of the strategies I put in place to make sure that we don't have any delay. Obviously, this system is very super smart to be able to look at the environment. Anybody who can be working around the machine, because in this machine is always people around, and the system should be able to look at the machine, I mean the line, and looking at the surrounding, any obstacles, any obstructions, and make decisions. So we never had those systems. And in the set of literature reviews, I have been spending more time to see that if somebody came up with this type of project and with the cost effective, because other people try to implement this, but with a very expensive type of equipment to be able to look at the surrounding, including the path or the way this thing is going. You will find this same type of technology right now in most of the cars where people are driving, the most expensive cars now. They're also introducing the same technology in aviations, which are different, very similar to this. But in the level of AGV, automated guide, it's not yet, except people using like a LiDAR stuff, and LiDAR is kind of very expensive compared to this tiny little camera cost about less than $100, and we multiply with times 200 piece of equipment on the plant. Our budget can fit on that, and plus we got a very sophisticated system. So that was basically the brief of my project. Obviously, this is going to be a project developed. I will have to develop and present all this over the 3 years, and I'm on my second year. So if everything goes well, I should be on my third year, basically facing most of my professors on and trying to prove the point of this thesis. So that's going to be all about my project. But this is just to give you summary of this actually what the camera sees. This is a grade level where we can do a lot of math calculations to be able to fill the gap of any missing parts of this project. I would like to emphasize, or I mean, to call your attention between these black line and this is invisible line. And obviously there's another line between any missing gaps where the system is able to loop around, check, project, and then keep going if everything is okay. Unless really we're losing a big chunk of this magnetic field or cover, then the system will be like, okay, I cannot do it. But you can always increase this blue uh, space or as a region of interest so that your threshold can be expanded and you can basically go for any part, I mean, a bigger part of anything missing. But right now, due to my I try to make my project to be very stronger. So I'm reducing the area and trying to make sure that this is able to track properly. So that's basically everything I had on my project. Thank you, Dr. Sharma.
Thank you, Jule, for sharing your experiences and the research topic. Very nice. Thank you so much. We appreciate your effort, and sorry for
Thank
keeping
you.
you awake till midnight.
Got no choice.
Thank you. Okay, so next speaker we have from South Africa, Mr. Garth Grubel. He's also a winner of a DEng conference 3-minute thesis presentation. Mr. Garth, please take over from here.
Thank you. Good day, everyone. I suppose I've got a non-traditional background for someone studying engineering because my background is in law, finance, and a bit of mathematics as well. I have worked primarily in financial markets. I spent some time with the electricity utility in South Africa, where I started getting exposed to some of the electricity related issues. And then I started a energy trading business. And it was whilst doing some aggregation work and optimization, trying to solve a particular problem for one of our customers, that I started to stumble upon what I thought was worthy of a doctoral thesis. And so I did come to EIT very much from an industry point of view, trying to solve a problem for a customer. My introduction to EIT was during the pandemic. I did a course on AI for grid management, and I particularly liked the delivery method. Being someone in South Africa and having this opportunity to then study at a institution that was remote from where I was, and it was through that, doing that course, I got exposure to EIT, and I then came to have a look at the DEng program. Now, previously, about 15 years ago, I started a PhD. It was a quantitative PhD, and the comments that Professor Kalam was making earlier about kind of being dropped in the deep end and having no support was definitely my experience. I was running an organization at that stage and trying to do the PhD part-time, and it just didn't work for me. So I was particularly attracted by the structured nature of this DEng program. And I'm now coming to the end of my first year. I'm doing it full time. And it certainly has met my expectations in terms of the structure and the support you get. So I must say this route I would very much recommend. So the problem I was seem to have lost a slide. There we go. So the problem that that I was trying to solve for a customer, which then kind of led to the bigger idea, is in South Africa we have a significant undersupply of generation, and we have got grid constraint problems. So therefore, load shedding has now become a feature of our system rather than a bug. The EAF, so that's the system availability, is sitting at the moment around 55%. And with the exception of a couple of days now, in early October, we've had load shedding every single day this year in the country, sometimes up to 12 hours a day. So this is playing havoc on the economy. It impacts employment significantly because companies are failing or having to adapt how they operate due to the load shedding. And we have a country with massive inequality differences, very high unemployment, and therefore it's a very, very real problem for us to solve. So the issue that I was looking at for this customer was, how can I protect them from the effects of load shedding? So this is a customer with a national footprint. They have facilities right around the country, and the idea is to set up a type of virtual smart grid. So it's combining this concept of a smart grid with the concept of a virtual power plant. The company has both cogeneration at some of its facilities. It's got curtailable load. There's some flexible load as well, because it's a big industrial company, but they also have agricultural land, and they have to use electric pumps to irrigate. And so you've got an ability to move around the load to a time when it suits you. So the idea here is to buy in a whole lot of independently generated power, use that in conjunction with the cogeneration and embedded generation, and then these flexible components of the load to balance this company's facilities around the country as a single unit. But if everyone sorts their own problems out, the remaining customers sitting on the grid end up carrying a bigger and bigger load. So what I'm looking to do is provide services back to the grid at the same time in the form of ancillary services, and then also be able to supply power into the balancing market. I think of particular interest to me are the effects on voltage and frequency stability, with a high penetration of renewable energy, and the consequent lack of inertia due to the reduced number of rotating machines. The grid becomes very twitchy, I suppose you could say, and therefore to be able to provide stability back at the point of connection is an important thing, and that becomes a rising tide that lifts all boats. So it's good for the company, but it's also good for the grid overall. And so by creating this balanced unit, you can ensure the profitability of the company. You can therefore ensure that you keep downward pressure on unemployment in the country, and it allows the company to contribute to the overall GDP of the country. And I think I'll leave it there. Thanks, Dr. V.
Okay, great. Thank you so much, Garth, for sharing your views about DEng program, and also sharing your research topic with us. Thank you so much. Okay, now let's quickly wrap up. So here in this session, we have covered almost everything what any candidate would like to know about DEng program, starting from what is the difference between DEng program and a regular PhD. Then what are the entry requirements, how to apply, what scholarships are available. So we have covered everything there. And if you have any question you want to still ask us, you can ask, or you can place the question in the chat box. We'll be happy to answer it. Here, what you see on this slide is also a request for feedback. So I request all the attendees to provide the feedback on this session through either by scanning the QR code, or you can also reply on the link provided in the chat box. If you do so, You'll be the part of prize draw to win either a EIT's gift merchandise pack or online ticket to the upcoming Hydrogen Safety Hazardous Area Conference in South Africa. So please scan it and provide us the feedback. And if you have any question or query, please you can ask us through chat box, or you can unmute yourself also and can ask the question. Okay, it seems uh, maybe if you I don't see any questions at the moment coming up. If you have any question, maybe later on also you can send us an email, and we'll be happy to reply you through email. Uh, with this, I will be closing this session. Once again, I thank all the participants for attending this session, and I also thank our speakers for joining us in this event. Thank you very much. And here we have the contact details. Thank you so much, one and all present here.